okay, integration by parts. That's the name of the method, okay, integration by parts method, or just integration by parts. Let's see what's going to be integration by parts means, okay, what's the formula? We just remember the product rule for differentiation. So recall that by the product rule, okay, product rule of differentiation. If you have two differentiable function f and g, derivative of f of x times g of x is what? Derivative of the first times second plus derivative of the second times first. So it's going to be derivative of the first one times second, which is going to be f prime of x times g of x. Okay, it's going to be plus derivative of a second one, g prime of x times the first one, f of x. That's a product rule. Okay, you know that any equation of differentiation equation would have equivalent form for the integrations. Okay, so equivalency, if you're integrating, okay, equivalently. So what we can do, we can integrate, okay, if you integrate it, it's going to be integral of f of x, g of x prime, dx, which is going to be equal to, this would be, okay, I'll just switch it, doesn't matter. It's going to be f of x, g prime of x, d of x, plus, and this would be g of x, f prime of x, d of x. Okay, so I integrate it. When you integrate this one, you get back to the, okay, original equation. It's just the integral of a differentiation. So that gives you f of x times g of x. Okay, on the other side, you are going to have the f of x, g prime of x, dx, plus, that give you g of x, f prime of x, dx. Okay, so this is going to be the case. Now I can, we can use another notation, okay, easier notation. So we are going to make it short. Suppose we have this notation. Suppose the u is going to be f of x, okay, and v is going to be g of x, u and the v. If this is going to be the case, then remember the differential. If you find the differential of the u, d of u, differential is going to be what? Is going to be the derivative times the dx. So in this case would be f prime of x times dx. That's the differential of the u. Find the differential of the v. Differential of the v simply would be what? Is going to be v prime times d of x. So the v prime would be g prime. So that gives you g prime of x, d of x. Okay, just changing the notation. So the conclusion is going to be, so this would be u times v. U times v is equal to the integral of f of x is u, g prime of x dx is differential of the v. So that gives you dv. It's a plus, the other way around, g of x is v, g of x would be v, and the f prime of x dx is going to be du. Okay, so u times v would be integral of u dv plus v du. So we are going to solve for one of these. We rewrite it. So I'm going to arrive at u dv is going to be equal to the u times v minus integral of the v differential of the u. You see this formula? This formula is going to be called integration by parts formula. Okay, integration integration by parts formula. Okay, so what is going to be the application? What does it mean? You see, this part integral of u dv is going to be an integral that you're going to find. So sometimes what we can do, we can reduce it. You see, we reduce it to the other part. So when you reduce it, probably, or you expect it, this second one would be easier to handle. Okay, so that's going to be, we call it integration by parts. So it's going to be two parts. One part is the one that you're going to find. So we reduce it to the easier parts. Sometimes you may, you may make a mistake, or you reduce it to the difficult one, which is not going to be a good one. So what we're going to do is we start with this. You have to identify the u and the dv. When you identify the u's, and then you need to find the differential of the u for the second part. And when you identify the dv, you have to integrate to get the v. Then you substitute and hope to be able to go to the second one. There are many integrals in calculus 2 and 3 that can be done by integration by parts only. Okay, only. So I'm going to give you various ones so that you get the feeling and get to know them. Okay, you can recognize it yourself that you have to use integration by parts formula. Okay, so the formula is, I just proved it for you so that you know that what's going to be the foundation of the arguments. But otherwise, it's important to be able to do it. So I give you various examples of the type that we are going to use integration by parts to take care of it. Okay, all of them are important, and you will see all of them in your next test. Okay, various categories. So I start with the most famous one. So we don't have to tell you that do it by integration by parts, because these are going to be the only methods. So example, we wanted to find each integral. Find each integral. The first group, or the most important one, is this is going to be integral of a power of x. It doesn't matter, whichever power you like. X squared to the 5th to the 6th. Or I can, I can start with this. And this one first. This is very popular. Integral of ln x dx. That's the most popular one. Then I extend it. This integral can be done only by integration by parts formula. So how are we going to do it? Just compare u dv. So if you compare them together, you have to pick the u to be ln x and the dv to be the dx. You have no other choice. Okay, so in this case, this is going to be a very unique problem. So the solution is going to be, you are going to pick the u to be ln x. That's your first step. A very important step, in fact. Okay, that we go for it. So u would be ln x. So automatically you have no other choice. Okay, that you have to pick the dv to be leftover. Leftover is going to be dx. That's a step one. Because you start with the formula, you see u dv. Then you have to know, you want to write the second part. So what you're going to do is, the one that you get the u, you have to find the differential of the u to get the du. The one that you get the dv, you integrate it to get the v. So the next step is going to be, the first one from the u, you find the du. Differential, you differentiate ln x is 1 over x multiplied by dx. That's going to be your du. Over here, you integrate. When you integrate, that give you v equal to integral of the dx. Integral of the dx would be x. You see, in general, it's x plus c, but we don't use the c. We need only one function of the x. Even if you use it, they will cancel out when you substitute. So why not? We are not going to use it. Okay, you take it, you pick the u and the dv. The part that you call it u, you have to find the du, differentiate. Differential ln x would be 1 over x times dx to make it differential. The second part, you integrate it. You integrate the dx, it's going to be just x. You don't need to have x plus c. Okay, go to the formula, substitute. You see, you substitute, what is going to be the case? So the original integral is ln x dx is equal to uv. U is ln x, v is x. So it's going to be x ln x ln x minus v du, integral of the v du, integral f, v is x times du. Du is what? Is 1 over x dx. That's it. Okay, it's going to be uv minus v du, because you start with the udv. uv, you multiply these two together, that give you x ln x minus v du, you multiply these two together, x dx. You simplify the second part, and you hope that the integral is easier to handle, which is the case. You see the x and x would cancel out, we get the integral of the dx. You see? The new part is easy to handle. Integral of a dx would be 1, would be x ln x minus, okay, minus what? It's going to be minus x. Since this is the end of the problem, you are going to add the constancy. So integral of ln x dx is equal to what? X ln x minus x plus c. A very popular formula for the integrations. Okay, so that gives you integral of ln x, integral of ln x dx. You have no other method. There is a method at the end of the course that we can apply to estimate this integral. But this is the only method for taking the integral of the ln x dx. Okay, so we simplify it. You see, the second part must be simpler, easier than the first part to handle. Otherwise, your choice isn't a good one. So the choice was clear, was unique. So I call this one u, the leftover would be dv automatically. So from the u, we differentiate 1x dx. From the dv, we integrate. So that gives us the x. You don't have to add the c here because this is not the final part of the problem. Then you form the formula. Integral of u dv would be u times v, uv, x ln x minus v du. V is the x, 1 over x dx. Simplify it, easy integral. It's integral of 1, which is x. And you add the constant c and you're done. Okay, so that's case 1. Integral of ln x dx. Case 2 for the ln's. Case 2 is going to be just a power of x times ln. You see that was ln x only. Case 2, you get various of this case in your book. Integral of any power you like. X squared to the 5th to the 6th, they are all the same. All the same. So I go with the x cubed. ln x dx. Okay, so you may have x to the 5th, x to the 6th in your book. Again, this can be done only by integration by parts. You have to pick the u and the dv carefully for this problem. Okay, so you have various choices. Okay, just think about it. Whatever you see, you have to pick the u, and the dv from this product. Think about the next step. From the u, you have to find the du. You see, the derivative is easy to handle. You can find it all the time. But from the dv, you have to find the v. You have to integrate, which is not easy. So for this group of problems, the suggestion is take u to be ln x all the time. because it's easy to find to find the derivative of ln x. It's very difficult to find the integral, because if you pick the ln x here, you have to integrate it. You know that you have to use integration by parts. So that's why the best choice is ln x. The leftover would be dv. The leftover is going to be x cubed dx dv, which is very easy to handle. If you want to find the integral of x cubed, you know that's going to be x fourth over 4, and do that. Okay, so for this group of problem, all the time, ln xu, leftover dv. So find the other side, easy. Derivative of d ln x would be 1 over x dx. Integrate. Integral of x cubed, I write it down for you. Integral of x cubed dx is going to be x to the 4th over 4. Remember, no constancy. Use the formula. X cubed ln x dx is u times v. You see, uv. This would be x to the 4th over 4 times ln x. That's u times v, minus integral of v du. V times du. V is x to the 4th over 4. Du is what? Is times it by 1 over x dx. That's it. You simplify this one. So what's going to be the leftover? X to the 4th over 4 ln x minus integral of what? The leftover is going to be x cubed over 3 dx. Very easy integral to find, because you pull out the 1/3 and you integrate. X to the 4th over 4 ln x minus 1/3 integral of x cubed dx. You integrate it, it's going to be x to the 4th over 4 ln x minus 1/3 integral of x cubed would be x to the 4th over 4. Now plus the constancy. Simplify it. X to the 4th over 4 ln x. Okay, minus. I missed something somewhere, because I should get the 16 here. That's it, that was a 4. Okay, sorry about that. That's 4. That is 4. That is 4. So I should get x to the 4th over 16 plus the constancy. That's it. This is the integral of x cubed ln x dx. Final answer. You see, very easy method for this group of the problem. So any power times the ln x. And they are going to be, we can make a formula for it, but we don't want. See, this is x cubed. That gives x to the 4th over 4. This would be x to the 4th over 16 plus c. So this means if it was something like x to the, okay, if you have x squared would be x to the 3rd over 3 ln x minus x to the 3rd over 9 plus c. If it is x to the 5th, x to the 6th over 6 minus x to the 6th over 36 plus c. So, you can find a general formula for all of them, but remember, on the test, you have to show your method. Okay, if you just write the final answer, you get 1 out of 10, remember, because all the calculators give you this result right away. It's integration by parts. So full details must be given to us, okay? You give us details and the final answer is going to be this one. Okay, so that's a group, a big group, a power of the x times ln x, any power. But make sure for all of them, u must be ln x. That's the key. U must be ln x, the leftover dv. The leftover is powers of x. It's always easy to know to integrate it. So make sure they start with the ln x to get these numbers. Okay, so that's a case 2 for these problems. Now, what's going to be case 3? Case 3 is interesting. Case 3 is, I did this one with the ln function. How about doing it with the exponential function. Okay, how about a power times e to the, you know that integral of e to the x is e to the x, so we have nothing to worry about. So how about x e to the x dx? Again, a power of the x times e to the x, any power, x squared to the third, to the fourth, to the sixth. It must be done by the integration by parts. Now, how are we going to pick the parts for this one? Solution. To pick the part, you need the u and you need the dv. Again, think about the next part. Whatever you get for the u, you have to differentiate it. Whatever you have to take the v, you have to integrate it. Let's see which choice is going to be better. You see, e to the x is easy function to handle. So if you take it to be u, the derivative would be just e to the x. If you take it to be dv, is the same thing. So that would be option. But how about the x? X, you see, if you take the x to be what? If you take the x to be dv, when you integrate it, the result would be x squared. It's difficult, more difficult to handle because you increase the power. So for this group of the problem, the best choice is take the u to be x. Because as soon as you differentiate it, that give you 1. Okay, of course, 1 times dx, which is the dx. So the dv would be e to the x dx. Why? Because that's easy to integrate. You know that the integral of e to the x would be just e to the x. So for this group of the problem, you better take the u to be x, okay? The dv would be 2e to the x because e to the x is easy to integrate. And if you put them together, you would find out that easily you have the solution. You see, use the formula x e to the x dx is equal to u times v, uv x e to the x minus v du, integral of v du, v is e to the x, and the du is dx, you see? And you know that integral of e to the x is just e to the x. So it's going to be x e to the x minus e to the x plus the constant c. So that's the famous x e to the x dx, which is going to be equal to the x e to the x, okay, minus e to the x plus the constant c, and you're done. Okay, so this is how we're going to handle integral of x e to the x dx. Okay, so I picked the u to be equal to the x. So the leftover dv is going to be e to the x dx. It's easy to integrate because the integral is the same. But since you pick the x, when you differentiate it, you reduce it to 1, which is very easy to handle. Okay, so that's x. Let's see, for the log function, natural log, it doesn't matter, x squared to the 5th to the 6th. All of them are going to be easy and one method, but not for this one. Let's try. Let's increase the power. X squared e to the x dx. It's how I'm going to find this one. Okay, the method would be the same solution. So we take the u to be equal to the x squared. Okay, the leftover, so the dv would be what? E to the x dx. So from this part, you have to differentiate it. The du would be 2x dx. Integral of x squared is 2x dx. And the v, integral of e to the x would be just e to the x. Okay, so put it inside the formula that we have. So integral of x squared e to the x dx would be equal to u times v. uv would be x squared e to the x minus what? Minus integral of v times du. So it's going to be 2x e to the x dx. You see this one? You can pull out the 2 if you like. You pull out the 2, that give you x squared e to the x minus 2 integral of x e to the x dx. You see this new one? This new one is a previous problem. See? X e to the x. So what we did, we just reduced this power. That was x squared. We reduced it to the x e to the x. Now, if it's going to be on the test, then you have to use integration by parts to find this one. You see? But in this problem, we have it. And we say, oh, I have it from the previous problem. But if it's going to be on the test, we have to find it. I have the fact that this is going to be x e to the x minus e to the x plus c, if you like. So go back and substitute here. Okay, substitute here to get the final answer. So you have x squared e to the x minus 2 what? Minus 2x e to the x plus 2e to the x plus c. So your result is going to be integral of x squared e to the x dx is going to be equal to, we have the x squared e to the x, but minus 2 times, okay, minus 2 times what? Times x e to the x minus e to the x. X e to the x minus e to the x plus the constant c. So if you distribute it, the final answer would be x squared e to the x dx, which is going to be x squared e to the x minus 2x e to the x, negative positive, plus 2e to the x plus the constant c. It doesn't matter, negative 2c or just c is the same thing. So that gives you the result of your integral. Okay, so the point is that if you want to find the x squared e to the x, it would be reduced to the x e to the x dx. Then you have to use that integration by parts. Similarly, if you want to find the x cubed e to the x, you will end up with the x squared e to the x. Then you have to find the x squared e to the x. You do integration by parts, you end up with the x e to the x. So if you want to do x to the fifth, so good luck. X to the fifth, you reduce it to the x to the fourth, then you have to reduce the fourth to the third, to the second, to 1. So it takes quite a while to be able to do this type of problems. So I'm going to give you a shortcut. This shortcut is not in your book, but you better learn this one. It's quite interesting, especially after this course. Probably you are going to take the course differential equation that I also teach that one. So in the case of the differential equation, this method is huge advantage. Okay, huge advantage. Okay, so what is going to be that shortcut? This shortcut was, it's a new, was early, I think 82, 83. It was given by one of the author of this calculus book. There is a calculus book, and the guy, I think his name is Orwaf. I can give you, the paper if you like. He called it, I will post that paper for you on the Canvas. You can have a look. He called it lazy student method of integrations. That's the topic of his paper. That's it, lazy students method, something like that. But I posted for you. You can have a look. The way he just proposes these methods that we do, we can put it into they call it a tabulated format. You see, the way we operate over here is going to be whatever we pick the u, we differentiate it. Whatever that we pick the dv, we integrate it. And just we repeat this procedure in both case. So you can do all of these for some special function, especially this one. In this format, you see you get a table. This table would have the following column. This column, I'm going to call it the sine column. the sign is going to be alternatively positive and negative. You see, positive, negative, positive, negative. This column is the column of differentiation. We call it prime column. And this column, we call it integration part. So for this one is like you put those U's. For this one is like the point, you know, the dv that you start with. So for x squared e to the x, what we did, the u part was x squared. So we put the x squared here. Okay. And the dv part was e to the x. So that would be e to the x to start with. Okay, so that's the x squared all the time for the first one and the leftover for the other one. So what we're going to do then, the second step, you differentiate this one. So that's the x squared, we differentiated, that give you it 2x. This part you integrate. Integral of e to the x is just e to the x. So it's going to be e to the x. You continue. You differentiate this one, integral of a 2x would be 2. You integrate this one, that give you e to the x again. You continue into different derivative of a 2 is 0. And the integral of e to the x is just e to the x. When you get the 0, you stop. Okay, this can be, it's going to be a stop because we're just using for the power of the x. So it's going to be x to the 5th. Eventually, that would end up with a 0. And this method can be used only if you terminate it, you get the 0. Then this is the way we're going to collect the result. So we multiply these numbers and give us the terms of the integration. You see, you multiply these two together, and these two together. So what's going to be the result? Integral of x squared e to the x dx is equal to positive sign x squared e to the x squared e to the x minus the second group, 2x times e to the x, 2x e to the x, plus what? 2e to the x, 2e to the x, plus the constant c. Done. Compare them together. Exactly the same one. You see, very nice methods. It's just x squared. When we get to the next chapter, we have something like x to the 4th, x to the 5th. This is e to the x. You can have e to the 3x, e to the 5x. So that would be such an important, techniques really. And if you're heading for some engineering discipline, this type of integration is going to be around forever. So you better learn this method. It's up to you. If you don't like it, you can use the integration by parts. I strongly suggested to you that use this method. Otherwise, on the test, some of the problems takes hours to do if you don't want to use that type of method. Okay, so we call it the tabulated method. It's a very valid and a very nice method to be able to do it. Okay, but in calculus books, if you take calculus Larsen, they talk about it, but I haven't seen it in Stuart. Okay, so how we're going to use it? We just use it for some special function when there's a power of x times e to the x, power of x times sine, cosine. These are going to be the important part of it. So I do one more for you so that you know how to do it. I just make it more complicated for you. Okay, so I repeat it again. This column must be powers of x. So whatever power is, you call it u. The leftover here. For the first column, you differentiate, you go down. Derivative of x squared 2x 2 0. You must end up with a 0. In this column, you integrate. Then the way you're going to collect the result, cross multiply. Then you're done. Okay, I'll give you one more, which is going to be more, not complicated, more involved really. This problem is going to be used 3 more times during this course. And then you appreciate this method, you see. Suppose you want to find this integral. Look at this one. Integral of x cubed e to the, this is actual one that we're going to use, negative 2x dx. These type of combinations are very popular in physics and when you want to do differential equation. Okay, so tabulated one. So the solution is going to be the table. This is the sign column. This is the prime. This is the integration. Okay, so the sign would be positive. You put the x cube here, and you put the e to the negative 2x. Now you start. The sign would be negative. You differentiate it. That give it 3x squared. You integrate it. Integral of e to the negative 2x is e to the negative 2x, remember, but you have to multiply u prime, which is a negative 2 here. So the integral would be e to the negative 2x divided by negative 2. Remember, when you differentiate it, it's e to the negative 2x times u prime, which is a negative 2. When you integrate it, the multiplication would change into the what? Into the division. So e to the negative 2x over negative 2. Okay, continue. Plus differentiate 6x. Integrate. So the integral is going to be e to the negative 2x again, but you have to divide by a negative 2. There is already one negative 2, negative 2, negative 2 would be a positive 4. Okay, integral of e to the negative 2x is again e to the negative 2x over negative 2. And you already got the negative 2 here. So negative would be positive. Okay, move on. Negative 6 derivative, integrate. Integral of e to the negative 2x would be again negative 2x divided by negative 2. There is a 4 here, negative 2 times 4, negative 8. Okay, once more. Derivative of a 6 is 0. So again, integral of e to the negative 2x is a negative 2x divided by negative 2. Negative 2 times negative 8 would be a positive 16. That's it. Collect the information. Cross multiply. Okay. If you want to do it, the actual one, you have to use integration by parts 3 times. So what's going to be the result? Carefully write the result. X cubed e to the negative 2x dx is equal to, first part, you write it down, then simplify. It's going to be x cubed times it by e to the negative 2x over negative 2. That's first one. Minus 3x squared times it by e to the negative 2x over 4 plus 6x. It's like the derivative, you see x cubed, 3x squared, 6x. 6x times e to the negative 2x times a negative 8 minus 6 times e to the negative 2x over a positive 16 plus the constant c. Okay, just like a cross multiplication. You have to simplify it a little bit to write it down. So the final answer is, this is going to be something like negative 1/2 x cubed e to the negative 2x. This would be minus a 3/4 x squared e to the negative 2x. Here minus 6/8, simplify it by 2. That give you 3/4 x e to the negative 2x. Simplify 6 and 16 by 2. So that give a negative 3/8 e to the negative 2x plus the constant c. Nice method. Okay. So this integral, I told you, at least 4 more times, you are going to use it in this course. Okay, even when we get to the last part of the course. Okay, so it's going to be very, very useful method for this type of procedure. Get through it. Okay, so it can be used over here, and another series of application problems that we have is going to be power of the x times sine or cosine. It would be the same thing. So I'll give you, this is going to be the next category. Again, if you don't want to use this tabulating method, it takes times. You can do it if you like. So let's try. Power of x, we can start with the x, sine or cosine. Sine of, let's say 3x dx. Again, you can do, you can do it directly if you like, but I prefer the table solution because we have so many to take care of. So why not get some easy method? So sine prime, integrate the sine positive, u function is x. The dv is going to be sine of the 3x. Okay, move on. Sine would be negative, derivative of x would be 1, integral of a sine. Integral of a sine is a negative cosine. Negative cosine of what? 3x, but you have to divide it by 3, u prime. Okay, you know that when you differentiate, it's going to be 3 cosine. Okay, 3 cosine, but when you integrate it, it's not 3 times, it's divided by 3. Okay, it's all the same. Then we continue, it's going to be positive. The derivative of 1 would be 0. Again, integral of a cosine is sine, so it's going to be negative sine of the 3x. But you have to divide it by 3. You already got another 3 that make it to the 9. Okay, integral of a cosine is sine of the 3x. You usually multiply by u prime, which is 3, but in this case, you divide it by 3. 3 times 3 would be 9. Okay, collect the information by cross multiplying. So what's going to be your result? Integral of x sine of the 3x dx is equal to, see, you write it down, then simplify it. X times negative cosine of the 3x over 3 minus 1 times the negative sine of the 3x over 9. So the final answer is going to be what? It's x sine of the 3x dx equal to what? Negative 1/3 of x cosine of the 3x. And negative positive plus 1/9 sine of the 3x. And do that. Okay, very nice method. So you can have a higher power. I'll give you another one with the cosine. So number 7. Okay, let's have another power, any power you like, it would be fine. Okay, let's have, x squared, because I want to finish it quickly. We can have x cubed to the 4th to the 5th. So how about x squared? Cosine of, let's say, 5x dx. Again, since it's the powers of the x, we try the tabulated method. Solution. Get the table. Okay. So again, it's a sine prime integral. So the sign is positive. U must be x squared. U must be a powers of the x. And the leftover is cosine of the 5x. Start differentiating so that you get to the 0. Over here, integrate all the time. Okay, so what's going to be the result? The sign would be negative, the derivative would be 2x. Integral of a cosine is sine. Sine of what? Sine of the 5x. So you have to divide by 5. Because when you differentiate it, you multiply by 5. When you integrate it, you have to divide by 5. So the sign would be positive. The derivative would be 2. Integrate the sine. Integral of a sine is a negative cosine. Negative cosine of what? 5x. So you have to divide by 5. But you already got another 5. 5, 5, 25. Okay, once more. Negative derivative of 2 is 0. Integral of a cosine is going to be sine. So it's going to be negative sine of what? Sine of the 5x. So you have to divide by 5. You already got the 25. So 5 times 25, 125. That's it. We complete the table. Okay, so you differentiate it, you must get 0 to, this method must be terminated somewhere. So in the first column, you differentiate. In the second column, you integrate. Now put them together to get your final answer. Cross multiply. So it's going to be the final answer. Integral of x squared cosine of the 5x dx is equal to the first group is going to be x squared times the sine of the 5x over 5 minus a 2x times this one times a negative cosine of the 5x over 25. Okay, up here, so plus 2 times what? 2 times a negative sine of the 5x over 125. So I add the constant c here. You have to simplify it, write it down nicely. So this is x squared cosine of the 5x dx. Now this would be what? It's going to be a fifth x squared sine of the 5x. This would be negative positive plus 2 over 25, okay, or 2x if you like, 2x 25 cosine of the 5x. And over here, it's a negative minus 2 over 125. 125, the sine of the 5x plus the constant c. Do that. Okay, so it's a great method. Take care of most of the application problems that we're going to have in future. Powers of the x times exponential function e to the x, powers of the x times sine and times cosine. Okay, that will take care of one trouble group if you like for us. Okay, so that's the third category. What's going to be the fourth one? The fourth one is inverse trigonometric function. Very important group. Okay, very important group. You must know how you integrate the famous function integral of a sine inverse, tangent inverse, and the secant inverse. Okay, all these three, you should do it, and you can do all of them only by integration by parts, and you have to go through it. So let's start with the famous one, integral of a tangent inverse. The only method that you can do the integral of a trigonometric function is integration by parts. Okay, so the choice is going to be unique. We have to do it. There is no table, no shortcut. So remember, you have to change this one to the UDV. So the solution is going to be, you have no other choice. You have to pick the U to be tan inverse. Okay, the leftover is going to be the dV must be dx. It's the only choice that we have. Okay, going the other way around, the other part. This is u, we need the du derivative. That's why we studied this derivative before, remember? Derivative of a tan inverse, remember? 1 over 1 plus x squared. That's the derivative of a tan inverse. But times dx, because this is differential. Okay, u tan inverse of x, dv dx. So in the terms of the v, that's easy. We integrate dx, we get the x. Okay, so to differentiate the first one, derivative of a tan inverse 1 over 1 plus x squared dx. And we integrate the second one, integral of a dx would be x. Go back, the formula, tan inverse of x dx is equal to uv x times tan inverse of x. Okay, x times tan inverse of x minus, remember v du. V is x, and this is 1 over 1 plus x squared dx. So that's the actual formula. Okay, integral of u dv is u times v minus integral of the v du. Now you have to take care of the other part. It's going to be x tan inverse of x minus integral of x over 1 plus x squared dx. Okay, the second part is easy to handle. So that's going to be x over 1 plus x squared dx. You have to use U substitution to get this one. You know that there is no power here. We stay here. We check the derivative on the top. You see the derivative of 1 plus x squared is 2x. So you can take the bottom one to be U, go to U substitution to get it, or just use the shortcut really. You see, if you take this one to be U for the U substitution, you need U prime on the top. U prime is 2x. So a 2 is missing. This is the way you can write down as a short form. 1/2 integral of 2x over 1 plus x squared dx. You see? Now, this is U. This is U prime. U prime U. You know that integral. U prime U is the derivative of ln function. So this would be 1/2 ln of 1 plus x squared plus c, if you like. Okay, that's a short form that you can use it if you like. Okay, because the U prime on the top, you just need the U prime to get it. And so you just go back and substitute, get the result. If you don't like this method, you see the other method. Some people don't like that method. So you have to use U substitution. You take the U to be 1 plus x squared, but we suggest this method really, it's going to be messy. But you have the option. So you have to find the du, which is going to be 2x dx. You have to find the dx, which is going to be the du over 2x. So your integral is x over 1 plus x squared dx is the integral of, you don't have anything for the x, don't worry. 1 plus x squared is u, and the dx is the du over 2x. So the x and x would cancel out. So that would be what? That would be 1/2 integral of 1 over u du, which is 1/2 of the ln u. Ln of the absolute value of u plus c. But what is u? U is 1 plus x squared. You don't need the absolute value because u is positive. Same thing. But we expect you to be able to quickly recognize it really would be better, but you have a choice, that's smart. So you need the u prime on the top. You see this 2x dx that you create here? That's a u prime. So a 2 is missing. When the number is missing, you can, if you need a 3, 1/3, 3. If you need a 5, 1/5, 5. Quickly you can give it, but otherwise you have the option, you can do it without mind. So the final answer, integral of a tan inverse of x dx is equal to x tangent inverse of x minus 1/2 ln of 1 plus x squared plus c. That would be the final answer. It's a very important result, and we maybe ask you to do it for us. Just make sure that you are ready for it, and that's going to be the tan inverse. Okay, so we can do the sine inverse as well. The second inverse we have to wait. We can't do it now, but we must do it sometimes. So let's do what's going to be the sine inverse. Again, integration by parts method. No other method can be applied. How about integral of a sine inverse? The cosine inverse is the same, so we don't usually give you that. Okay, again, integration by parts. The choice is clear. U would be sine inverse of x. So the dv is going to be dx. You have no other option. So from the u, you have to find the du. derivative, you know that derivative of a sine inverse is 1 square root of 1 minus x squared dx. Okay, that's a du, and the v is going to be just x. Okay, go back, substitute the formula. Integral of a sine inverse of x dx is equal to u times v, uv. So it's going to be x sine inverse of x minus v du. V is x, du. Du is what? 1 over the square root of 1 minus x squared dx. So the result is x sine inverse of x minus integral of x over the square root of 1 minus x squared dx. You have to take care of this integral. You see, you have to find this one. Again, you can use the shortcut or just use substitution. You know that you change the radical, you move it up. It's going to be x times 1 minus x squared to the negative half dx. Now you need a u substitution. You take the u to be, it can be also done, shortcut. So u would be 1 minus x squared. You have to find the du, which is negative 2x dx. Then you have to find the dx, which is going to be the du over negative 2x. Okay, you have to use the u substitution for all of them. Go back, substitute. So integral of the x times 1 minus x squared to the negative half dx is equal to integral of, we don't have anything for the x, don't worry. It's going to be canceling out. 1 minus x squared is u, so it's going to be u to the negative half dx, and the dx is the du over negative 2x. Simplify the x. The leftover would be negative half integral of u to the negative half du. Okay, and this integral is going to be what? It's a negative half u to the, add 1 to the power, negative 1/2 plus 1 would be a positive half, divided by the positive half plus c. So these two would cancel out. You get negative u to the half. But what is u? U is 1 minus x squared. So it's going to be negative 1 minus x squared to the half plus c. Okay, so remember you are here. So you go back. So what's going to be your final answer? The final answer, integral of sine inverse of x dx is equal to, you have the uv x sine inverse of x minus this integral. Negative would be positive. So that gives you 1 minus x squared to the half plus c. You can write the, the half as a radical if you like. You don't have to, but it's a very famous result. X sine inverse of x plus the square root of 1 minus x squared plus c. So that gives you integral of the sine inverse. Okay, they are very, very similar. Okay, for the secant, you have to wait. You cannot do it now. There is a method that we cannot use it. So we make a note, but we leave it for when we get to the next section, then we're able to do the secant inverse. Okay, so you know all of them. Sine inverse, tangent inverse, secant inverse. The cosecant, cotan are similar. We don't usually go with those. Okay, so that would be another group of the examples that we have. There is one more. When you're doing things in physics, especially if you are heading for physics or electrical engineering. That a square root, something like sine of the radical x, cosine of the radical x, or the sine inverse of the radical x, or the tangent inverse of the radical x are very popular. So you should have a good idea of how to take care of this type of integrations. They must be done by the integration by parts. So I just remind you those as well, okay? Because again, these are the ones that you are going to use in future if you take differential equation or some other courses. Okay, so that would be the next group or the final group. Study this one carefully. You have quite a lot of problems in your book, and I post your practice test so you can see, the idea of. But we give you one from each of these categories in your next test. Okay, so the number 10. So you have all of them here, really. Just study it carefully. You see, it's going to be this type of function. You may be given something like, how about integral of cosine of the radical x dx? The famous one, of course, is sine inverse and the tangent inverse, and we have them in your practice test. Then I take care of those one for you too. You see, if you want to integrate this type of function, there are different ways to do it. My suggestion is get rid of that radical x first. Okay, because if you want to stay, some people stay with this one, but it would be messy. So I'm going to get rid of it, just use a substitution to get rid of the radical. So you may call x what? Call it t squared, u squared, it doesn't matter. So my suggestion is that get rid of it. So we call it a mini substitution, if you like. The mini substitution would be you let x to be equal to the t squared. But you know that you have to take care of the dx too. So if you take x equal to the t squared, so the dx would be what? Dx is going to be 2t dt. Go back and substitute. Then you will be surprised when you get the result. If you substitute, what's going to be the result? Integral of cosine of the radical x dx is going to be equal to integral of, you see, the radical x would be t now, because you replace the x by t squared. So that gives you cosine of t times it by, times it of what? Times it by the dx. Your dx would be 2t dt. So if you switch it, you are going to have the integral of what? 2t cosine of the t dt. You see? It's the power of the t times cosine of t. You have to use integration by parts, but you can use that table. You can use the shortcut. Remember, the shortcut can be applied because this is just the power of the x. Okay, so as soon as you switch it, if you like, then you get the situation that you can use the table. So we are going to use the table to take care of it. Okay, so what's going to be this one? This is going to be the sine prime. You integrate. The sign would be positive, so we pick the 2t here. And we put the cosine of the t here to integrate it, the leftover. We continue to get the 0. Okay, this is going to be negative. You differentiate it, that give you 2. Integral of a cosine would be sine t. Once more, this is going to be positive, so that would be 0. Integral of a sine would be negative cosine t. And we are ready. You see, this is it. So the integral of 2t cosine of the t dt is going to be equal to what? 2t times sine t, 2t sine t minus 2 times negative, you see, 2 times negative cosine t plus c. So the result is going to be 2t sine t, negative positive, plus 2 cosine t plus c. But you have to get back, and remember the t what's the t? X was t squared, and the t is radical x. So you substitute, because your result must be in terms of the t, so it's going to be what? So originally, integral of a cosine of the radical x dx is going to be equal to, okay, 2t sine, the t is radical x, so it's going to be 2 radical x sine of the radical x plus 2 cosine of the radical x plus c, the final answer. Okay, some people, they don't use the t, and then it's going to be very messy, and they don't use the table. Because if you don't change it to the t, then you cannot use the table. So make sure to change it to the t first. You change it to the t, and easily you can, you can take care of it. That will give you that, that format that we're going to have. Okay, so it can come with the cosine of the radical x, okay, sine of the radical x to get these numbers. Okay, now this can come with that trigonometric function that we have. It can come with the tangent, secant, sine inverse. Okay, sine inverse. And I didn't do the secant inverse for you, but I do the secant inverse of the radical x, which is a very popular problem. Okay, so be careful. You will see it later on in your various practice one that we give you. So this is a very popular secant inverse of the radical x. You can have it with the tangent, which is very popular. I write it down here so you make a note. I do it when I go with the practice test, because I review the practice test for you. I didn't do the quiz, but I do the tests. So these two, this is a very popular. Let's see. Again, you say, you better do that mini substitution, otherwise you'll be in trouble. So this is it, solution. Mini substitution. X equal to what? T squared. And then the dx is equal to 2t dt. Okay. Substitute, change it. Integral of a secant inverse of the radical x dx is equal to, okay, equal what? It's a secant inverse of radical x. The radical x would be just t times it by dx, which is the 2t dt. Okay, so you are going to get integral of a 2t secant inverse of the t dt. That's it. Remember, for the secant inverse or the tan inverse, you cannot use the table. So you have to go directly to your integration by parts method. Okay, so this is going to be the by parts for this one. For the by part one, you have to take the u to be secant inverse of the t. So the dv is going to be 2t dt. It's important to make sure you get the proper parts. You know that when you're dealing with the inverse function, always u is going to be that inverse function, because we know the derivative of the inverse function. We don't know the integral of those. Okay, so differentiate du. Remember, derivative of a secant, 1 t, the square root of t squared minus 1 dt. This is the only place that you need to know the derivative of a secant inverse, okay? Remember, it was 1 over x radical x squared minus 1. So that can be dv. Now what's going to be v? So the v would be what? V is the integral of a 2t dt, which is t squared. Because the derivative of t squared is 2t and no constancy. Okay, now put them together. So what we have? 2t secant inverse of t dt is uv. u v t squared secant inverse of t minus integral of v du. What is v? T squared. What is du? You see, that's it. 1 over t square root of t squared minus 1 dt. So that gives it a chance to simplify these two, and you get the integral that we did it before. So it's going to be t squared secant inverse of t minus integral of what? T over the square root of t squared minus 1 dt. Okay, that would be the integral of the, so far, of course. Okay, so far is integral of sine inverse of x radical x, but you have to take care of this integral as I did it for the previous problem. Remember, it's a u substitution type. I do a shortcut for you for this one so that you can see the both methods. So that gives you t squared minus 1 dt. In the previous problem I did it, I take the u, and you see if you take this one to be, sorry, that's a negative 1/2. So if you take this one to be u, you see u prime would be 2t. You need a 2 here if you want to use the shortcut. So you write down as a 1/2 integral of a 2t t squared minus 1 to the negative half dt. You see if you switch this one to get that shortcut, it's going to be t squared minus 1 to the negative 1/2 the 2t dt. Now this is u, this is du. If you like this method, otherwise, like the previous one that I did, use substitution. Okay, so this is going to be 1/2 of the u to the half, because negative half plus 1 plus the constant c. Okay, you substitute for the u, so that's going to be 1/2 square root of t squared minus 1 plus c. If you don't like this method, you see I did it here for you. You see, x over radical 1 minus x is x squared minus 1. You just switch it. So this is going to be another method. But this method is much easier. You can pick whatever you feel more comfortable. Okay, so if you have to go back and substitute, so eventually this is the final answer. Sine inverse of the radical x. Sorry. Is it sine inverse? No, secant inverse. Secant. Okay, so this is it's a very popular problem. So secant inverse of the radical x dx, you end up with what? We have t squared secant inverse of t, now here, minus half square root of t squared minus 1 plus c. Now you have to substitute for the t. Remember the t squared was x. So the final answer is going to be look like t squared secant inverse of the, sorry, that is, let me rewrite it for you. You see, remember x is t squared and the radical x is t. So if you substitute here, what's going to be the final answer? So the final answer is going to be, I just write it down here for you. So what's going to be the final answer? This is it. Integral of a secant inverse of the radical x dx is equal to t squared is x, is going to be x secant inverse of radical x minus half a square root of x minus 1 plus the constant c. Very popular result is secant inverse of the radical x. Okay, so these are, you have to read these examples carefully. I gave you everything you need, really. These are the best problem for the integration by parts. There are only two more that it would be too much for tonight. I give you this one again. There are two famous problems that we use in differential equation later on. We call it Laplace transform. And I talk about that one at the beginning of the next recording that we're going to have, so that you can have them as well. Otherwise, you have all the possibility. So read these examples carefully. And if you have any question, just let me know. You can come to the Zoom, but you have to email me. You email me in advance so we can arrange a time so we can come together and explain it for you again. Because these are going to be very important, really, this integration by parts. We're going to have some other techniques, but this is the one. If you want to go on take calculus 3, we needed quite a lot over there. All these examples are going to be used in that course, and of course in that differential equation course. It's going to be huge application over there. All the integrations in that course. This is going to be the last course that you take if you're heading for engineering discipline. So for all the problems on that course, you need the integration by parts methods. Such an important one. Okay, that's 7.1. And the next group are going to be integral of the trigonometric function. It's not bad. It's very messy in your book. So I post another lecture for you. I go over that one too. That's 7.2. 7, 3, and the 4 are easier. We check the integration of the rational function. It's a little bit heavy. We're not going to rush it to see how far we can go for your next test. Probably just maybe 1 or 2 sections. Okay, more section, because they are heavy, I know that. But go over it. If you have any difficulty, let me know. Okay, have a good one. Take care. Over the weekend, I'll look at your quiz, okay, and your assignment. So I will post